Hello, this is Colin Goebel. In this video, I'd like to extend the bouncy ball demo into the second step, Bouncy Ball Step 2. And what's going to happen in this demo is I'd like to take a look at how we might program several balls bouncing around the screen independently. To show you what I mean, let's take a look at the application as it's finalized. I'll once again click on the green arrow to start debugging. And this time you'll notice we've got a collection of 5 balls and they're all bouncing around independently. Okay, let's take a look at what we had to change from step 1 in order to do that. Same include darkgdk.h for the darkgdk functionality. In this case, however, we've got 5 ball objects, and as you know, each of them is, as you observed, each of them was moving around the screen independently. So for each of the 5 balls, we needed to record a value for its x coordinate, a value for its y coordinate, a value for its coordinate of speed and, for its component of speed in the x direction, and a value for its component of speed in the y direction. And since each ball has its own individual sprite to represent it, each ball also has a unique ID so that darkgdk can distinguish one ball from another. In order to support 5 balls or 10 balls or whatever we may have, I'm going to program this as an array of balls. And as you've seen here, each ball is a struct. Notice I've used the struct construct with a capital B here for the ball type. Each ball has those 5 fields: an ID, a position, and a velocity, an ID, a position vector, and a velocity vector. Five numbers that describe the state of each ball. Okay, here we have a number of balls. For this particular demo it was 5, but I could make it 6 or 7 by just changing that number. We have a window width. I didn't change it. Window height, didn't change it. We have the same background color, and we're using the same ball image, which I gave, again, the unique number of 1 to. So nothing changed there. Our main loop here, or our main function, remember we're not using main, we're using darkgdk. No changes there. We set the display mode. We set the frame refresh to 60 frames a second. We disable the escape key. We initialize the timer. We load the ball object. Right here we load the ball object. And by the way, the background color on the ball, the background on the ball image is set to black. And so, as I mentioned earlier, we need to set the image color key to 000. That specifies the color black, and that means the black background of the ball will be transparent. So the image color key here, db set image color key, specifies the transparent color for the image that we're next loading. For our ball object, if you look at it in Paint or something, you'll see the background of that ball image is colored black. And we want that to be transparent because we want the gray background of the screen of the window to show through. Okay, here we're declaring an array of 5 balls. So the array is called balls with a lowercase b. The array is an array of objects of type ball. So each object in the array is a ball struct, and there are 5 of them. So we put the number 5, number of balls is equivalent to 5, in square brackets. So this is simply an array declaration. Balls is the identifier. It says balls is an array of 5 ball structs. Now what we have to do is initialize each of them. So we have a simple loop here which counts from 0 to 4. That gives us the 5 balls, 0, 1, 2, 3, 4. And the loop initializes each of the ball structs. Right there is the beginning and the end of the loop. So for each of the 5 balls, we set the x field, the x coordinate, to a number between 50 and 150. dbrand window width minus 100 is going to give us a number a random number 50 anywhere between 50 pixels from the left hand margin of the window and 50 pixels from the right hand margin of the window. We need to set the y coordinate to a random number between the top of the window and the bottom of the window, and this piece of math does that. It should make it at least 50 pixels from the top of the window and at least 50 pixels from the bottom of the window. If you do the math on that, you might see how that works. As previously, we want each ball to go in a random direction, so we set the dx component of the ball to the same formula we used before. We set the dy component of the ith ball there. We're going to take the ith ball of the array, set the dx component to that function. We're going to set the dy component to that function. And then we give each ball a unique ID. So I'm going to give the 0th ball in the array an ID of 1, the second ball an ID of 2, and so on. So each ball there has a unique ID. And having created that ball, we now have to create the sprite and render the sprite on the screen. So once again, we call the dbSprite function. The ID for that particular sprite is the ID number we created right here. So bullseye.id is the ID. The x coordinate for that ball is bullseye.x. The y coordinate is bullseye.y. And the image that we're going to use for that sprite, for all 5 of them actually, is image number 1, img ball. Okay, so this defines the 5 sprites, ball sprites. It locates them on the screen, and now we're ready for our main loop. As before, it starts here, while loop gdk, and ends right here. So there's the beginning and end of the loop. And the code here is really very similar to what we have before. We are going to keep looping all the time loop GDK is true. We don't have to worry about that. That's functionality provided by darkgdk. We set the screen background to gray. But now we have 5 balls we have to move. So there's an inner loop here. We're going to loop over the 5 balls that we have in our collection. That for statement in I equals 0, I less than 5, I plus plus, means we're going to repeat that block of code for each of the 5 balls, numbered 0, 1, 2, 3, and 4. For each ball, we are going to change x by the amount of the velocity component in the x direction. We increment y by the velocity component in the y direction. And for the case of each ball, we have to see if that ball has hit the left-hand margin of the window, or the right-hand margin, or the top margin, or the bottom margin of the window. And in each case, if that ball hits one of the margins of the window, we have to reverse its velocity either horizontally or vertically as necessary. So the code is exactly the same as you saw in step 1, except that instead of making those calculations for one ball, we now iterate through an array of ball structs and make those calculations for each of the 5 balls. Having moved each ball, mathematically, we now have to render each ball on the screen. So we've got 5 of them to render, a little loop here for 5 balls, and that statement there, again, the same statement you saw before. We're going to render bullseye.id. That identifies which one that the sprite renders. It renders it in the coordinates x and y, and it uses the ball image to do so. And nothing else really changed in this program. When we escape out of the loop, we've got 5 sprites that we need to clean up instead of 1, and we've still got 1 image that we need to clean up. So once again, here we go. It's much the same as before, except there are the 5 balls all moving around independently. Thank you.